So for our first one, this one's pretty straightforward. We're adding. We start on the right, work our way back to the left. 3 plus 4 is 7. 7 plus 8 is 15, so 5, carry the 1. And 1 and 4 make 5, plus 2 is 7. So we're at 757 for the first one. How many of you had that for the first one? Good deal. The second one, subtraction, this one's a little tricky. We didn't do any examples that had zeros in it like that last class. We start out 6 minus 9 can't be done, so we have to borrow. The problem is there's nothing here to borrow from. So we have to keep going. Well, there's nothing here to borrow from either, so we have to go all the way to the 7. So that becomes a 6, and this is now a 10. But we don't need it here. We need it all the way down here at the 6. So we have to keep borrowing. Borrow, and that's a 9. Now this becomes a 10. Borrow again, that's a 9, and now this is a 16. And now we have everything borrowed to where we need it. 16 minus 9 is 7. 9 minus 8 is 1. 9 minus 5 is 4. And 6 minus 2 is 4. 4417. How many had that? Okay. Multiplication's a little bit more strenuous. So we're starting with the last digit of the bottom number. 4 times 7 is 28, so it's 8, carry the 2. 4 times 5 is 20, plus the 2 is 22, so it's 2, carry over the 2. Now before we move over to the 3, we've got to put a 0 here. I put a line across up here above all the numbers I carried. That way I know anything that I carry new, I'm going to put above the line, so I don't get confused when I come, is this to a new carry or an old carry? Okay. So now I'm going back down. I'm going to use the 3. 3 times 7 is 21. So 1, carry the 2. Notice I'm putting it above the line. 3 times 5 is 15. Plus, that 2 is a new carry, so 17. 7, carry the 1. I have 8 and 0 is 8. 2 and 1 is 3. 2 and 7 is 9 and 1. So 1,938. How many of you had that one? Good. So to do the 5,848 divided by 34, I have to put it in my long form like this. Is the easiest way, at least for me it is. 34 does not go into 5, so I leave it blank above the 5. 34 does go into 58. Goes in there once. I put a 1 above the 58. 1 times 34 is 34. I subtract, I get 4 and 2. Bring down my next digit, which is the 4. 34 goes into 244. Let's see, is 8 going to go? Probably not 8. Let's do 7. 7 times 4 is 28. Carry the 2. 7 times 3 is 21. Plus 2 is 23. So subtracting there, I'm going to borrow to make this a 14. Gives me 6. Bring down my 8. 34 goes into 68 twice. 2 times 34 is 68. So nothing left. So 172, how many had that? Just a couple of you. Yeah, the long division's harder. Some of you probably just didn't have time to finish it up. Now, I will never on a quiz or test force you to do that without a calculator. I'll tell you that now. You will always have the calculator available. I just wanted to have these few problems up here to see if you remember the processes. And it is good to know how to do it by hand. In my former life, before I started teaching, I was a structural engineer, and several times I'd end up on a job site where sand got into the keys of my calculator, and either one or more of the keys didn't work. So I either had to make do without it or calculate without the calculator at all. Or my calculator would get hot in the sun and it wouldn't be working right. So I've had several times where I've had to do some relatively complicated calculations by hand, just because the calculator that I thought was going to be there wasn't. Okay, anyway, with that, I understand that in Richmond your books have not come in.
That's correct.
Okay. Well, our first homework assignment is going to be tonight, and it'll be due on Tuesday. So hopefully they come in tomorrow, but I'm not going to hold my breath. If they don't, just let me know, and I'll just have to extend the assignment for Tuesday for you so you have more time to do it. If they do come in tomorrow, try to get onto my math lab and get logged in and get yourself registered. For those of you that have your books, is anybody having problems getting registered in my math lab?
I just have a question.
Yes.
So when I signed up, I meant to sign up for this class, but I was originally, I accidentally did the Wrights Lake campus one.
Okay.
And I got the email during that, and I just got switched over to this one. But I still follow the same instructions
Yep.
in that email.
Still the exact same instructions. Yeah, it's all in one My Math Lab site.
Okay. Thank you.
You bet. That's actually pretty common that people get signed up for the wrong location.
Yeah.
Okay, so for those of you that are in my math lab, our new homework when I assign it tonight, when you get in here, working a little slow, you'll see on the dashboard here, there is one that pops up, homework 1 due September 6th, which is next Tuesday. You should be able to open it there, or you just click on homework, and it'll be there. There you can click on your questions and work on them. If you have any problems, let me know and I'll help you get in there. We'll have some time at the end of class for those of you here that have your books. I can make sure everybody's registered for it as well. At the end of class, like I said, I'll say a little bit more about that. I'll make sure you know what our assignment is. It'll be homework 1 assigned for Tuesday. So anyway, let's go ahead and get started with our new material. Like I said, hopefully those books come in and we have everything working well by the end of the day tomorrow for you so you can work on the homework over the weekend. Okay, so last class we talked about the parts of a number and place values, and we even looked at basic calculations with whole numbers. Today I want to step back a little bit and look at what does it mean to combine values. I mean, we did the long addition like this here, but when we did the 3 plus 4 and got 7, why is it that 3 plus 4 equals 7? I mean, we've been taught all sorts of representations for doing addition, like 5 plus 3. One of them you've been taught, you might do 5 sticks and 3 sticks. To add them together, you count them all together and you get 8 sticks, right? Or maybe you used your fingers or started counting up from on a number line. Well, to represent the technical representation of 5 plus 3 requires us to represent the values 5 and 3. And to do that, we do actually use a number line. There are a couple of different ways to represent a value on the number line. Let's look at 5, for example. One way would be to put just a dot at 5. Now, if I have several numbers that I just want to place them on the number line and represent them, that is a very good way of doing it. It's compact. But if we want to do something with it, like addition, that's not a terribly useful representation. A more useful representation, a more working representation, is what we call a vector. Now, a vector is a really fancy word for a pretty simple concept. All a vector does is it's just an arrow that starts at 0 and it goes to the value. So the vector for 5 looks like that. And actually, the vector for 5 does not have to start at 0. I can take that and move it wherever I want to. There, it starts at 4 and it goes to 9. It's just an arrow that goes 5 units in the positive direction. So then, of course, a 3 would start at 0 and go to 3. It goes 3 units in the positive direction. The operation of addition literally means to combine. So when we're adding 5 and 3, what we're doing is we are combining their vectors. Like that. So now we can see that we have one big long vector that goes from 0 to 8. Now we all knew before that 5 plus 3 equals 8. We didn't need to draw out our vectors to figure that out. But the reason I'm showing you this is, get this out of the way, come on. What if we run into a problem like this? 5 plus a negative 3. Well, to make this work, we have to define what does it mean. Well, first we have to represent our negative 3. And representing that's pretty simple. Just go from 0 to negative 3. It's the same length as our vector for 3. It just goes the opposite direction. And when we go to combine those, we put that with our 5. Now, since they go in opposite directions, they work against each other. So the value is the difference between their lengths, which is 2. 5 plus negative 3 is 2. Now, I went through all this not because I want you to draw number lines to add numbers. I don't draw out number lines even to add numbers, even though I'm working with negatives. But I do keep that picture in my mind. If I have something like a negative 17 plus 42, I'm thinking this. Here's 0. Negative 17 goes in the negative direction. Positive 42 goes the opposite direction, and it's longer. Those are the two questions I have to ask. Does it go the same direction or the opposite? And is it shorter or longer? It goes the opposite direction and it's longer, so it goes past 0. So what this picture tells me, first of all, my answer is positive because I'm on the positive side of 0. It also tells me that since my arrows go in the opposite direction, that my result is the difference between the values. The difference between 17 and 42 can be found by subtracting 42 minus 17. I get 5 and 2, I get 25. So negative 17 plus 42 is a positive 25. I might have a negative 23 plus 19. So I'm going to get a similar picture. Here's 0. Negative 23 goes in the negative direction. Positive 19 goes the opposite direction. Is it longer or shorter? It's shorter, yes, slightly shorter. So this tells me that I ended up on the negative side of 0. So my answer is negative. The arrow is still going opposite directions, so my result is the difference in values. The difference between 23 and 19 is 4. So again, negative 4. So I might have a negative 31 plus a negative 27. Well, here's 0. Negative 31 goes in the negative direction. Negative 27, same direction or opposite? Same direction, right? It's negative as well. So what this picture is telling me, we're obviously on the negative side because they both go negative. Are we adding the values or subtracting the values? Adding them because they both go in the same direction. 31 plus 27 gives us 58. So my result is a negative 58. What I'm doing there is something called absolute value. I use the negatives to give me the direction of the arrows. That tells me when the answer is positive, negative. But you notice here, when I'm doing the 31 and 27, I ignore the negatives. That's its absolute value. That's the length of its vector. It's called the absolute value. So I don't care what direction it's going at that point. I'm just looking at the length of its vector. So it's at 53 plus a negative 24. I want you to try that one in your notes quick. So we have 53 goes in the positive direction. Negative 24, same direction or opposite? Opposite, shorter or longer? Shorter. So we end up on the positive side. Adding or subtracting? Subtracting. 29. Positive 29. How many of you had that? Okay, good. The reason I spent so much time dealing with the details of addition is the next step is to talk about subtraction. And subtraction gets to be a lot more complicated. Now look at the problem 8 minus 3. Now, pretty much all of you, or probably all of you could tell me that that is what? 5. Good. How would we represent that on the number line? Well, here's 8. Subtracting 3 goes back this way. Well, how is this picture here different from what if I had 8 plus a negative 3? What's the difference between those two pictures? Well, technically, it's a trick question. There is no difference. They're the exact same picture because these are the exact same problem. There are a few different definitions for subtraction. One of them is that this symbol means add the opposite of the number that comes after it. So what that means, if I have 13 plus a negative 17, I did that backwards again, sorry. Let's say I have 13 minus 17. What that's telling me to do, the first number doesn't change, the 13 stays, but instead of subtracting 17, this is telling me to add the opposite of that. So I'm going to add, what's the opposite of 17? Negative 17. And now I can just use those vectors. Here's 0, positive 13, negative 17 is the opposite direction and slightly longer. My answer is negative. The difference between 13 and 17 is 4. I might have negative 18 minus 23. Well, what happens with the negative 18? Nothing, right? Then the subtraction, we're going to change that to plus the opposite of 23, which is negative 23. So instead of subtracting 23, we're adding a negative 23. And for our picture, here's 0. Negative 18 goes negative. Negative 23, same or opposite? Same. So this is telling us our answer is a negative. And we combine the values, add the values. 18 and 23 make 41. Where subtraction gets really tricky is when we run into something like this. (14 minus a negative 8). Now the 14 doesn't change. The first number always stays the same. This symbol is telling us to add the opposite of that. So we're going to add, what's the opposite of negative 8? Positive 8. So 14 minus a negative 8 becomes 14 plus 8. So I don't even need to draw the picture. 14 plus 8, that's 22. I want to warn you a little bit. It gets taught, and a lot of people say it. Well, 2 negatives make a positive. Be careful. I mean, in this case, when applied properly, it's true. Subtracting a negative does make plus a positive. And in some other cases, it's true. But it's not a general rule. It does not work in all cases. I mean, we had cases up here where 2 negatives, negative 31 plus negative 27, did not make a positive. It made negative 58. So it's not a hard and fast rule. 2 negatives in the right place turn into a positive. So what if we have negative 27 minus negative 12. What's this going to become? Perfect. Negative 27 plus the opposite of negative 12 is a positive 12. Negative 27 plus 12. Negative 27 plus 12, what's that become? Negative, opposite direction, so the difference between 27 and 12 is 15. Or we might have negative 32 minus negative 49. That's going to become, what happens to the negative 32? Nothing, right? Then what? Plus, what's the opposite of negative 49? Positive 49, or just 49. So here's 0, we got negative 32. Positive 49 goes the opposite direction and is slightly longer. So our answer is positive 17. Good. The difference between 32 and 49 is 17. Any questions? Better than a sharp stick in the eye? For now? Okay. Let's take a look at multiplication. We talked a little bit last class about the definition of multiplication. 5 times 3 is defined to be 3 5s added together. 5 plus 5 plus 5 gives us 15. So in that light, when we look at negatives or integers, negative 5 times 3, well, that's simply 3 negative 5s added together. Negative 5 plus negative 5 plus negative 5, which gives us negative 15. Now 5 times a negative 3, we have to do a little bit more adjusting. By the way, what we could do, we don't have to have the multiplication symbol in there. We could just have the negative 3 in parentheses and the 5 in front of it. Anytime there's a number outside of parentheses with no symbol, that does mean multiplication. But anyway, back to this. Is it possible to take negative 3 5s and add them together? To add 5 to itself negative 3 times? No, it's not. So that doesn't really make sense. But what we can do is we can use the property that multiplication can be switched. You can change the order of the two numbers in multiplication and it doesn't change anything. It's called the commutative property, but I'm not really concerned that you know that word. So we can do, instead of 5 times negative 3, we can do negative 3 times 5. And what that's saying then is that we're going to have 5 negative 3's added together. Negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3, which is still negative 15. Many of you are probably taught negative times a positive is negative. Positive times a negative is negative. You probably even took the next step. Negative 5 times negative 3. A negative times a negative is a positive. So what's that going to be? Positive 15. Good. Why? Well, because negative times a negative is a positive, right? Why is a negative times a negative a positive? Just is. Right? That's what we were told. What's that? They cancel each other out is one of the things we've been told. How do they cancel each other out? Well, to be honest, all those things are standard answers that most teachers give. The truth is, you really can't multiply negative 5 times negative 3 if you only use the definition of multiplication. I can't take negative 5 and add it to itself negative 3 times. If I switch it, I can't take negative 3 and add it to itself negative 5 times. So my definition of multiplication doesn't work for this problem. And that actually happens in math more often than you would think. So what we do is we use a pattern. We take things that do work We had our negative 5 times 3, and what was that? Negative 15. So now we're going to try to establish a pattern to get to this. So I'm going to keep the negative 5, but I'm going to change the 3 to 2. What's negative 5 times 2? Negative 10. Again, I keep the negative 5. I went from 3 to 2, now let's go to 2 to 1. Negative 5 times 1 is negative 5. Now let's look for a pattern here. Each time I started with the number negative 5, and I multiplied it by something. I reduced the number I multiplied by 1. Went from 3 down to 2. What did it do to my answer? Well, it went from negative 15 to negative 10. It went up. It increased by 5. Here, I went down by 1 again. This increased by 5. Now let's see if that pattern will continue. I start with negative 5 again. To continue my pattern, what do I have to multiply by here? 0. I have to decrease by 1. 1 minus 1 would be 0. What's my answer going to be? 0. Anything times 0 is 0. Did this increase by 5 again? Sure did. It went from negative 5 up to 0. So that pattern appears to be true. So let's continue it. Negative 5 times negative 1. I decreased the 0 by 1 to get negative 1. That's got to equal, if I have to increase this by 5, what do I get? Positive 5. Negative 5 times negative 2. I'll have to increase this by 5 again to get positive 10. Negative 5 times negative 3 has to go up by 5 more to 15. So you guys all knew that two negatives have to multiply to make a positive. That right there is why. It's the only reason why two negatives multiply to make a positive is it keeps this pattern going. Otherwise, by basic definition of multiplication, you cannot multiply two negatives. So from that, if I have a positive number times a negative number, is my answer positive or negative? Negative, right? Positive times a negative is a negative. Once I've determined what my sign is going to be, that my answer is going to be a negative, then I can ignore the signs and just multiply. What's 7 times 4? 28. So 7 times negative 4 is a negative 28. If I have a negative 5 times 8, a negative times a positive is still a negative. Good. Now that I've determined that my answer is negative, I can ignore all the negatives and just multiply the numbers. What's 5 times 8? 40. Good. Or I can take a negative times another negative. Of course, a negative times a negative is positive. Now that I have my answers positive, I can ignore the negatives and just do 9 times 2 is 18. Good. One thing your book likes to do is to get a little absurd with these a bit. Does stuff like that. When we multiply, well, actually, most of our operations are what we call binary operations. We can only work with two numbers at once. So that's all we're going to do is we're going to start with the negative 2 times negative 2, which is positive, right? And 2 times 2 is 4. Now I'm going to combine that with the next negative 2. What's 4 times negative 2? Positive times a negative is negative. 4 times 2 is 8. Then I multiply that with the last negative 2. Negative times a negative is positive, and then 8 times 2, 16. Good. Let's look at division. Division is defined as part of multiplication. We mentioned this last time. Multiplication and division are the same operation, just multiplication is going forward, division is going in reverse. So technically the definition of like 21 divided by 3, of course we all know that equals 7, but I'm going to leave a blank there for now. What that's asking is what number times 3 equals 21. And as we said, we can just fill in 7 there. We know that result is 7, because 7 times 3 is 21. Using that reasoning, we can figure out what our positives and negatives have to be. So if I have a negative 30 divided by 5, to figure out what that has to be. Well, that's saying what times 5 equals negative 30. Well, to get a negative number when we multiply, remember there was two possibilities. Either we had to have a positive and a negative, or a negative and a positive. We had to have one of each, right? So since we have a negative result, we know that we have to have one positive and one negative. 5 is positive, which means this number has to be negative. So it's negative 6, of course. So negative 30 divided by 5 is a negative 6, because it would take a negative 6 times 5 to give us a negative 30. (24) divided by a negative 6 equals blank. Again, that's asking us to solve this multiplication problem. What number times negative 6 equals 24? Now, when we multiply, if we get a positive result, there's one of two possibilities. Either both numbers were positive, or both were negative. Well, this one's negative, which means this one must also be negative. So negative 4 times negative 6 is positive 24. That's a negative 4. What we've seen here so far is our pattern for multiplication is holding true. A negative divided by a positive, just like a negative times a positive, makes a negative result. Positive divided by a negative, just like a positive times a negative, makes a negative result. Let's see if this continues for two negatives. If I have a negative 42 divided by a negative 6, well, that is asking what number times negative 6 equals negative 42. So again, thinking back to multiplication. If the result of multiplication is negative, that means we must have inputs that are one positive and one negative. The 6 is negative, so this number has to be positive 7. So, comparing it to multiplication, when we divide a negative by a negative, we get a positive. Just like in multiplication, if we multiply a negative times a negative, we get a positive. Any questions? Well, then the next step, let's look at something like this. What does that notation there mean? 7 with that little 3 there. That's 7 to the 3rd power. And how would we calculate it? Yeah. Perfect. It's repeated multiplication. It is 3 7s multiplied together, which is going to give you 343, right? How many of you have your calculators with you tonight? Most of you do? So quite a few of you do? Okay. On your calculators, depending on what calculator you have, if you have a 2-line display, TI-30, let's see, I'm trying to remember on the TI-30, it's over on the left side, halfway down about, it looks like that. It's called a caret key. If you have the 1-line display, TI-30 or Casio, It's usually over on the right side, just a couple of keys down. And it's either x to the y or y to the x. If you're using a cell phone calculator, most cell phones use one of those as well. They might actually look like this. It's the same thing. That's x to the y. So to enter this in your calculator, 7 to the third power, you type in 7, press whatever key you have, and then 3, and hit equals. So I'll race you. 8 to the fourth power. What are you going to get? $4,096? Perfect. Five to the sixth power. What's that? You're on the cell phone. Do you have a button that looks like that? X with a little Y after it. So you would enter for like 8 to the fourth power. You do 8, then that key, and then 4. That should give you 4,086. Okay. Perfect. Any other questions on getting your button to work on your calculator? Okay. Good. Try to do -5 squared. Now, first of all, you got to figure out how to enter a negative on your calculator. Depending on your calculator, if you have the 2-line display, down by your equal sign here, you'll have a button that looks something like this. It's a negative sign in parentheses. That is your negative. To use that, you would press that key, then the 5. That's a -5. If you have the 1-line display TI or most of your Casios and Sharps, the button you have looks like this. It's called the swap sign key, and it works a little bit backwards. To use that key, you would type in the 5 first, press the swap sign, and the calculator makes it negative. So you have to enter the number first and then make it negative. Some of your cell phones have various different keys that I can't keep track of all of them. Some of your cell phones, you just use the minus key from up here in your operations as well. Most of your regular calculators, if you try to do that, it's going to give you an error. It won't work. So let's look now at that -5 squared. Now, most of your calculators, you won't have to use the caret key or the x to the y key to square it. Most of your calculators have an actual button dedicated for power of 2. So it's just an x squared key. For the TI, it's over on the left side, right above or below the caret key. So you type in your -5 and hit squared. What does your calculator tell you? Okay. Some of you are getting 25. Did anybody get -25? Okay. Good. The reason for that, technically, -5 times a -5, a negative times a negative is a positive. Should be getting 25. But your calculator follows something we're going to discuss in the next hour, a very strict order of operations. And in order of operations, a power happens before a negative. So if you enter -5 squared like that, your calculator is squaring the 5 to get 25. And then putting the negative on it. So what you have to do on your calculator is you have to do parentheses, -5, close parentheses, and then squared to get it to do 25. So when you do a power of a negative number on your calculator, you have to put parentheses around it. Some of your calculators don't require that. Make sure you know, because I see a lot of mistakes made on tests where people go to square something and they don't use the parentheses and it comes up negative. You can never square something and get a negative answer. Anything times itself will be positive because, as we've said, a positive times a positive is positive, and negative times a negative is positive. So anything squared will be positive. So let's have you try negative 3 to the power of 5. Did you get negative 243?
Yeah.
That is perfect. Why is that one negative when our squares were all positive? So this negative 3 times negative 3 would be a positive 9. Then times the next negative 3, 9 times negative 3 is a negative 27. Negative 27 times negative 3, negative times negative is a positive. 27 times 3 is 81. And now it's 81 times a negative 3. Positive times a negative is a negative. 81 times 3 is 243. What's special about that power that allowed it to be negative? It's odd. If it's an even power, as you can see here, it went from positive to positive, and then back to negative again. If it's an even power, it's going to end on a positive answer. So we are out of time for our first hour, so let's go ahead and take our break there.